Morning. Right, we're going to look at multiplying bases now. You probably kind of know roughly what's going on already, but let's firm it all up. If I do 2 squared, 2 to the 2, that's obviously 4, as we learnt last time. I do like base 2, as you may have noticed. It's alright, it's quite a platonic relationship. There's certainly no reciprocation. Right, that's 8. Again, we should know that from last time. So what would happen if we did 2 squared times 2 cubed? In other words, times 2 to the 3. Well, presumably would have 4 times 8. Now that's going to give me 32. I'm going to have to underline that, obviously. My students will understand. I can't leave that sitting there without double underlining. It's just wrong. It's wrong. Okay, now, totally off the top of my head, I'm going to write down 2 to the 5 now. Don't know why. No reason, really. And if you type that into your calculator, look, you'll get 32. Now, there's a problem with you typing that into your calculator, clearly. The first problem is you've got to go to the crucifix encrusted box that the calculator's in, wave some garlic over it, disinter it from the ground, because calculators are the spawn of the devil and they shouldn't be allowed. The second problem with using your calculator is you'll probably only get to use it once, because I'm going to charge around your house and break your elbows if you do. But every once in a while I'll let you use it. There you go. There's one of the every once in a whiles. That would seem to imply something. I wonder what that something is. I wonder what that something, well, that's terrible, is. Well, look, the reason why when you multiply the same base, here are bases, when you multiply them you add the indices or the exponents, is actually fairly straightforward, because look, if I look at 2 squared, it's 2 times 2. And then if I look at 2 cubed, it's 2 times 2. This is interesting, isn't it? I was going to do this pre-written, but then why miss out on the fun of me drawing this? And sitting in between them, we've got a whopping great big times. Oh, that is bad. Now, one of my students who looked at one of these the other day asked me, where are the brackets? Where are the brackets? Brackets, man. And the reason I don't do brackets when teaching this bit is because it's harder to see the product chain. See what I did there? Product chain. That is comedy gold. I said that the other day when I was teaching, and I actually wrote it down. I thought it was so funny. So that's 4 times 8, which is 32. Yeah, let's just underline that. So obviously, it's a compulsion. What can I say? It's wrong. So hopefully you can see from this that there seems to be an indicator that when you multiply the same base, you will add the powers. You'll add the indices. Let's go and check that. Right. Let's check that first of all. Let's just see if it does work with some other numbers. So let's try, I don't know, pushing the boat out, base 3. Okay, 3 squared times 3 to the 1. Well, 3 squared is 9 times 3 to the 1, which is 3. And that of course gives 27. But hang on, we're saying that when you do this, you are adding the exponents when you multiply the same base. Let's see if that works. Well, 2 plus 1 gives me 3 to the 3. And again, if you type that in your calculator, you will indeed get 27. Oh my goodness! What have I done? What have I done? Poor mathematical working. I feel wrong. Okay, so that should make sense, right? Let's check it, or show you some things using base C. I'm using base C because I'm desperately lazy. I don't want to use X, because if you use X, you're going X times X. The X's look like timeses. It takes forever to write. This is going to be tediously dull at the best of times. Believe me, you're going to be sitting here watching me write C's across the page in a minute. So I'll use C because it's nice and quick. So base C could be anything. If I do C to the 4 times C to the 3, as you know, that should be C to the 7. And that's because we've got to see. I warned you. I did warn you. Go make yourself a cup of tea. I might even try and neaten this up by, oh, look at that. I've used my little keyboard shortcut to make the diagonals, if you're wondering why they're so neat. Yeah, that's worth it. I'll do that again in a minute. So look, we've got an unbroken product chain there. Okay. So 1, 2, 3, 4, 5, 6, 7. It is 7 lots of C. Stop me. Someone stop me, please. Now, I just want to show you something which links with the first tutorial. If we now do C to the 4 times C to the 3, but now we multiply it by C to the 0, what we've got is C times, oh dear. There has to be another way. I was going to pre-draw these, as I said, but you're just missing out. You're missing out on the joy of watching me, aren't you? And multiply it by 1, don't we? Because you may recall from the first tutorial, we said that that was 1. I haven't explained it yet. In fact, this is going to help me explain it. We're heading towards an explanation, but this is a way of showing you that that must be true, or hopefully showing you it must be true. Because if we now add these three together, we would of course get C to the 3 plus 4 plus 3 plus 0, which is 7. And this hasn't changed. This and this are the same. So of course, that should be C to the 7. If the naught was anything other than 1, this wouldn't work, would it? If this was 2 or C, I mean, this is the thing that many people think. Maybe it's C, maybe it's 0. I mean, if we put 0 in there, well, anything times 0 would be 0, but it's not 0. So it's a way of showing that C to the 0 isn't 0 and it must be 1. It still doesn't prove that to us, but at least we're getting closer. Yeah, I do just need to do something before we finished. Yeah, I'm feeling better now. Okay, right. Hopefully that's sorted out some of your stuff to do with multiplication. Let's do some division.